Dark islands of space. The phrase dark islands of space is not recognized in the context of modern astronomy or astrophysics. So what do the authors of the Urantia book mean when using this terminology? Let's look at the clues found in the book. The dark islands of space are classified as one of the 5 major divisions of spheres. Alongside stars, minor space bodies, planets, and architectural spheres. Dark islands are sometimes central to a solar system and orbited by planets, moons, and meteors. Dark islands sometimes orbit stars as a part of their solar family. So what astronomical objects would best fit within this description? Brown dwarfs are substellar objects that are not massive enough to sustain nuclear fusion, but too massive to be considered a planet. They range in a mass from around 13 times to about 80 times the mass of Jupiter. The existence of brown dwarfs were first theorized in the 1960s, and the term brown dwarf was first coined in 1975. As brown dwarfs have relatively low surface temperatures, they are not very bright at visible wavelengths, emitting most of their light in the infrared. Thus, the word dark is a proper description. Brown dwarfs are spheres. Most brown dwarfs form similarly to stars and are surrounded by protoplanetary disks. Over time, the disks accrete into planets, much like how systems form around stars. Many brown dwarfs have been discovered orbiting other stars, and even other brown dwarfs in binary configurations. With this information, we can conclude that brown dwarfs are indeed dark islands of space. But are brown dwarfs the only objects that fit the description? Let's look at another clue. Some of the dark islands of space are burned-out isolated suns, all available space energy having been emitted. These are the dead suns and other large aggregations of matter, devoid of light and heat. A black dwarf is a theoretical stellar remnant, specifically a white dwarf that has cooled sufficiently to no longer emit sufficient heat or light. The current age of the universe is estimated to be around 13.8 billion years, which is significantly shorter than the estimated time required for a star to cool down completely and become a black dwarf. Therefore, black dwarfs are not expected to exist in the universe at this point in time. However, the Urantia book indicates that the universe is far older than the current estimates of our astronomers. In this incredibly old universe, burned-out dead suns are bound to be quite common. There is possible evidence of their existence, as astronomers have witnessed stars disappearing and have yet to fully understand why. There even exists a project, VASCO, in which the search for vanishing stars is a primary objective. Could some of these vanishing stars simply have burned out? And are there any other objects that may fit the description of a dark island of space? Let us look at another clue. The dark islands are sometimes enormous in mass and exert a powerful influence in universe equilibrium and energy manipulation. The density of some of these large masses is well nigh unbelievable. And this great concentration of mass enables these dark islands to function as powerful balance wheels, holding large neighboring systems in effective leash. A black hole is a massive amount of matter so densely compacted that not even light can escape its gravity. They cannot be directly observed because they do not emit light. However, scientists can infer their presence by observing the effects they have on nearby matter and light. In 2017, scientists around the globe trained their telescopes at the heart of galaxy M87, and in 2019, they released the first ever photo of a black hole. Much is debated in the scientific community as to what these objects really are. There is consensus, however, that black holes exist in the center of most galaxies, and that they provide an equilibrium which helps keep galaxies in balance. Is the Urantia book referring to all three of these objects when using the description dark islands of space? Let us know your thoughts in the comments.